Hey everyone, and welcome. You know that feeling, right? You open up a course syllabus and you're just hit with this wall of text, a long list of dense, abstract topics that you know are important, but you have no idea how they all connect in the real world. Well, today we're going to change that. We are going on a journey to turn that confusing list into a tangible working program. I mean, just look at this. This is what Unit 1 of a standard C++ data structures course can feel like. It's just a sea of concepts, pointers, polymorphism, inheritance. I like to call it the C++ gauntlet. It's so easy to get lost in the definitions of each little piece and totally miss the big picture. And that's the million-dollar question, isn't it? Memorizing what a pointer is doesn't really help if you don't know why on earth you would ever need one. So how do we connect these dots? How do we go from all this theory to an actual functioning program? So here's what we're going to do. We're going to give ourselves a simple, practical mission. We're not just going to learn the concepts, we're going to use them to build a basic student roster. This little project will be our guide, and it's going to show us exactly why each piece of that syllabus actually matters. Our goal is super simple. Create a program that can manage a list of students. Each student has a name and an ID. That's it. But as you'll see, this seemingly simple task is going to unlock the true power and purpose behind some of those really complex C++ concepts. All right, so where do we even begin? Let's start by grabbing the most straightforward tool we have in our C++ toolbox. We need a list, right? And the first thing that pops into most programmers' heads is a simple array. Let's see how that works out for us. Okay, version 1. We declare an array of strings to hold, let's say, 10 student names. It's simple, it's clean, and hey, it works, for the first 10 students. But what happens when student number 11 walks in the door? Our program breaks. There's no more room. And that is the fundamental, critical flaw of a basic array. And this right here perfectly illustrates the core difference between static and dynamic data structures. Our array is static. Its size is locked in the moment we write the code. Sure, it's simple and fast, but that fixed size is a deal breaker for pretty much any real-world situation where data changes. What we really need is something dynamic, a structure that can grow and shrink as our student roster changes. Now, before we solve that size problem, let's fix another issue. Right now, we're just storing names, but what about the student IDs? We need a way to group that information together logically, and this is where we level up our thinking. It's time to start thinking in objects. So let's grab one of the most powerful concepts from our syllabus, the class. The best way to think of a class is like a blueprint. It's not the house itself, but it's the detailed plan for how to build one. In our case, it's the plan for what a student should look like inside our program. And look at how clean this is. We define a class and we call it student. Inside, we just specify that every single student is going to have a name, which is a string, and a student underscore ID, which is an integer. Just like that, we've created our very own custom data type, one that's perfectly suited for our problem. I mean, this is a huge step forward. Instead of trying to juggle a separate array for names and another one for IDs and hoping they stay in sync, we now have this single logical student unit. It makes our code so much cleaner, more intuitive, and way easier to manage. Okay, so we've got our amazing student blueprint, but we still have our original problem, right? How do we create a list of these students that can actually grow whenever we need it to? We know a simple array won't cut it. It's time to unlock some real dynamic power. And the key to unlocking that power is another one of those intimidating words from the syllabus, the pointer. But really, don't let it scare you. A pointer is just a special kind of variable. Its only job is to hold the memory address of something else. It doesn't hold the student data itself, it just knows exactly where to find it. Using them is basically a three-step process. First, you declare a pointer that knows how to find a student object. Second, you use the new keyword, which is like asking the computer for a fresh chunk of memory, just enough for one student. Then you store that memory's address in your pointer. And third, you use that pointer to get to the data and assign values, like setting the student's name to Alex. And just like that, we've done it. By using pointers and dynamically allocating memory with new, we can create a new student object anytime we want. Student number 11, no problem. Student 111, bring it on. Our roster is no longer trapped by a fixed size. We have solved our core problem. So let's just zoom out for a second. We took on a really simple problem, a student roster, and just by solving it, we navigated some of the most important concepts from our entire course. So why does this hands-on approach matter so much? Well, think about what we just did. We didn't just define a bunch of terms. We used an array and immediately saw where it falls short. Then we used classes and objects to model our data in a much smarter way. And finally, we used pointers and dynamic memory to completely overcome the array's critical flaw. We turned these abstract concepts into actual tools to solve a real problem.
And this is exactly what the course is designed to teach you. Look, the goal isn't just to remember facts. The biggest part of learning this stuff is being able to apply it. It's about analyzing a problem, evaluating different options, like we did with static arrays versus a dynamic approach, and then applying the right concepts to build a real solution.
So here's the key takeaway. Every single topic in that syllabus, from linked lists to sorting algorithms, is a tool in your toolbox. The goal of this course isn't for you to build a collection of tools you can name, but to become a skilled craftsperson who knows exactly which tool to pull out to solve a specific problem. And speaking of problems, you know how it goes. You solve one, and you create a brand new one. Our roster can now grow to 1 million students, which is awesome. But what happens when you need to find Alex's student ID? Are you really going to check every single student one by one? How do we find someone quickly and efficiently? And that question? Well, that's exactly what the rest of the syllabus is for.